This video is on terms that you need to know to understand solutions. So make sure you're paying attention and you're learning these definitions. So first, it goes way back, but a solution is a homogeneous mixture of two or more substances. So remember, homogeneous means it looks the same throughout. So you have things mixed together, not chemically combined, but they're mixed, but it all looks the same. Like a glass of Kool-Aid would be a homogeneous mixture. Coffee would be a homogeneous mixture. So they have two parts always. The solvent is the component that's present in the greater quantity. So what you have more of. This is typically going to be what does the dissolving. The solute, on the other hand, is what you have then in the smaller quantity. And this is the thing that is dissolved. And there can be more than one. You can have multiple solutes. Now, an aqueous solution is just a specific type of solution, which we've talked about. That's when the dissolving medium, so what does the dissolving, is water. So most often when we're talking about solutions, they will be aqueous solutions. So you can change within the same type of solution the amount of solute. So if you add more solute, so that's what's being dissolved, or you decrease your amount of solvent. So let's say you add more sugar to Kool-Aid, or you decrease the water in Kool-Aid. The name for that is the solution becomes more concentrated. Now, the reverse of that, if you are able to actually decrease how much solute or increase how much solvent, the solution becomes more dilute. So typically in these two cases, this is easier to do when we're trying to make something more concentrated. It's easier to add more solute. When you want to make something dilute, usually we add more solvent, like you'd add more water to make something more dilute. To make something more concentrated, we'd add more of, let's say, our sugar, whatever it is that's being dissolved. All right, so solubility is the ability of a substance to be dissolved and form a solution. So every solution has their own amount of how much can be dissolved in a certain amount of solvent. When you've got the most dissolved possible, that's called a saturated solution. So saturated is a solution that contains the maximum amount of dissolved solute. So you literally cannot dissolve any more in that amount of solvent. So if you add any additional solute, it will not dissolve. So an unsaturated, there should be a D right here for unsaturated solution is one then that isn't full, isn't saturated. So it contains less than the max. Amount of dissolved solute. So it's less than a saturated solution. So if you add more solute, it will dissolve because it's not full. All right, so then there's also such a thing as supersaturated. So this is a solution that contains more dissolved solute than a saturated solution. And if you're thinking, well, saturated is the maximum, how can you add more than the max? Well, it's a very unstable solution. Usually to get this to happen, you have to heat the solution to get more to dissolve, and then you have to cool it down. Okay, so it's generally unstable. So what that means is sometimes the slightest bumping of it, or if you add just one more piece, or we call that one more piece, we call it a seed crystal. So if you add one more crystal or seed crystal of solute, It will cause the excess, so the extra that you were able to get to dissolve, it'll cause it to crystallize. Okay, so this heating then cooling relates to the last part, and that solubility is affected by temperature. So the higher the temperature, typically, the more solute that can get dissolved. Okay, so let's add that note here. So usually more solute will dissolve at higher temps. And do a capital T for temperature. Okay, so let's look at two examples. So using this chart, you can see on the x-axis we have the temperature, and I want you to notice it's a little off, like the way the numbers are. Like this is 10, this is 20, 30, here's 40, here's 50, here's 60, 70, 80, 90, and this is 100. Just a heads up. All right, so temperatures on the x, so as temperature changes, we can measure on the y the grams of solute, so the mass of how much will dissolve in 100 grams of water. So if we have 100 grams of water, how much can we dissolve? So we're going to look at this NaNO3. So I've got a whole bunch of different substances. The NaNO3 is this line right here. Okay. And we want to know how much will dissolve in 100 grams of water at 10 degrees Celsius. So I'm going to find 10 Celsius, which is right down here, on that line, which is right here. So I can dissolve 80 grams. Oh, that's terrible. Let's try that again. Okay. All right, so now let's look at same substance. Let's do 80 Celsius though, not 90. So just edit your sheet. All right, so 80 is this one right here. So if I go up to the line, same one, and then I look over, I've got 140 grams. So as you can see, most of these, just like I said, usually more solute will dissolve at higher temperatures. Most of them have some sort of angle upward, or a lot versus a little, but most of them have angled upward. So as you get more energy, higher temperature, more will dissolve. The only exception to that is the NH3, the ammonia. All right, so those are your solubility term or solution terms that you need to know.